and pressure. Learning about gravitational force. Gravitational force. You know that a coin or a pen falls to the ground when it is slipped off your hand. The leaves or fruits also fall to the ground when they get detached from the plant. Have you ever wondered why it is so? Objects or things fall towards the earth because it pulls them. This force is called the force of gravity or just gravity. This is an attractive force. The force of gravity acts on all the objects. The force of gravity acts on all of us and all the time without our being aware of it. Water begins to flow towards the ground as soon as we open a tap due to the force of gravity. Gravity is not a property of the earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object. This force is known as gravitational force. Pressure. We all know that strong winds during a storm or a cyclone can blow away even the rooftops. We also know that winds and cyclones are caused by the differences in air pressure. There is surely relation between pressure and force. Try to push a nail into a wooden plank by its head. Did you succeed? No. Try now to push the nail by the pointed end. Could you do it this time? Yes. Do you get the feeling that the area over where the force is applied, for example, the pointed end of the nail, plays a role in making these tasks easier? Yes. Note that the area is in the denominator in the above expression. So, the smaller the area, larger the pressure on a surface for the same force. The area of the pointed end of the nail is much smaller than that of its head. The same force, therefore, produces a pressure sufficient to push the pointed end of the nail into the wooden plank. The force acting on a unit area of a surface is called pressure. Pressure is equal to force upon area on which it acts. I now understand why porters place on their heads a round piece of cloth when they have to carry heavy loads. By this, they increase the area of contact of load with their head. So, the pressure on their head is reduced and they find it easier to carry the load. Do liquids and gases also exert pressure? Does it also depend on the area on which the force acts? Activity. Take a transparent glass tube or a plastic pipe. The length of the pipe or tube should be around 15 cm and its diameter should be 5 to 7.5 cm. Also take a piece of thin sheet of good quality rubber, say a rubber balloon. Stretch the rubber sheet tightly over one end of the pipe. Hold the pipe at the middle. Keep it in a vertical position. Ask one of your friends to pour some water in the pipe. Does the rubber sheet bulge out? Note also the height of the water column in the pipe. Pour some more water. Observe again the bulge in the rubber sheet and the height of the water column in the pipe. Pressure exerted by the water at the bottom of the container depends on the height of its column. Activity. Take a plastic bottle. You can take a discarded water or soft drink bottle. Fix a cylindrical glass tube a few centimeters long near its bottom. You can do so by slightly heating one end of the glass tube and then quickly inserting it in the bottom of the bottle. Make sure that the water does not leak from the joint. If there is any leakage, seal it with a molten wax. Cover the mouth of the glass tube with a thin rubber sheet. Now, fill the bottle up to half with water. The rubber sheet fixed to the glass tube bulged this time. Pour some more water in the bottle. Is there any change in the bulge of the rubber sheet? Note that the rubber sheet has been fixed on the side of the container and not at the bottom. The bulging of the rubber sheet in this case indicates that water exerts pressure on the sides of the container as well. Activity: take an empty plastic bottle or a cylindrical container. You can take a used tin of talcum powder or a plastic bottle. Drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. The water coming out of the holes fall at the same distance from the bottle. This indicates liquids exert equal pressure at the same depth. When you inflate a balloon, we have to close its mouth so that the gas in the balloon does not escape. If we open the mouth of an inflated balloon, the air or gas escapes from it. Suppose you have a balloon which has holes. Would you be able to inflate it? The balloon will not be inflated because it won't be able to hold the gas or air in it. Can we say that air exerts pressure in all directions? These observations suggest that air exerts pressure on the inner walls of an inflated balloon. So, we find that gases too exert pressure on the walls of their container. Atmospheric pressure. We all know that there is air all around us. This envelope of air is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. We know that pressure is force per unit area. If we imagine a unit area and a very long cylinder standing on it filled with air, then the weight of the air in this cylinder is the atmospheric pressure. But how large or small is the atmospheric pressure? Let us get an idea about its magnitude. Activity: take a good quality rubber sucker. It looks like a small rubber cap. Press it hard on a smooth plain surface. Does it stick to the surface? Now try to pull it off the surface. Can you do it? When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of the atmosphere acts on it. To pull the sucker off the surface, the applied force should be larger enough to overcome the atmospheric pressure. This activity might give you an idea about the magnitude of the atmospheric pressure. In fact, it would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. If the area of my head were 10 centimeter into 10 centimeter, how much weight of air would I be carrying on my head? Does it give you an idea of how large the atmospheric pressure is? The weight of air in the column of the height of the atmosphere and the area 10 by 10 centimeter is as large as 1000 kilogram. The reason we are not crushed under this weight is that the pressure inside our bodies is also equal to the atmospheric pressure and cancels the pressure from the outside. Summary: force per unit area is called pressure. Liquids and gases exert pressure on the walls of their containers. The pressure exerted by air around us is known as atmospheric pressure. That is all in this chapter, students. Learning is fun.